Oh, hi. Hello, everyone. I want to ask a question to you guys. Do you love watching movies? Or do you enjoy or spend your free time watching movies, such as action, horror, stuff like that? Well, I personally watch movies during my leisure time. And today, we're going to explore how machine learning transformed the way we discover and enjoy movies. Our topic is movie recommendation system, and we'll dive into how platforms like Netflix and other movie platforms that we use nowadays, how it used advanced algorithms to personalize your viewing experience. Are you not even curious how they know what movies they will recommend after just watching one movie? Well, you will know how it works in this presentation, okay? I'm Christian Dale Gopez, joined by Janelle Gabriel Ong and John Hope David, and we'll show you through the world of machine learning in entertainment. So, before going further in our topic, the movie recommendation, let us first have a brief explanation on what is machine learning. So, again, machine learning is a subdomain of artificial intelligence. It is not the AI itself. It focuses on enabling computers and machines to imitate the way that humans learn, to perform tasks autonomously, and to improve their performance more efficiently by exposing it to more data. Okay, always remember that machine learning is not the AI itself, but it is a branch of artificial intelligence. It involves using data-driven algorithms to build models that can learn on their own. How amazing is that? These models can make predictions and identify patterns without the need for direct human programming, as they are programmed to actually analyze data and make decisions based on those. Today, machine learning is widely applied in various industries. For example, recommending products based on the purchase history, forecasting stock market trends, and translating languages automatically, and also our topic, the movie recommendations. So moving on in our main topic, which is the movie recommendation system. So what is a movie recommendation system and how or why is it useful? So movie recommendation systems suggest film based on your preferences. It analyzes your behavior, what you watch, you like or skip, you put into favorites, such as those, and use that data to suggest new content. I think you may have experienced this using social media. You've seen this in action also in Netflix, Disney Plus, and other movie platforms. They rely on classification, which is the process of sorting data into categories like labeling movie as action, comedy, or drama. So traditional recommendation system help users find relevant content or products by predicting user preference based on historical data. What have you watched? What have you liked? What have you disliked? It analyzes the data since it focuses on the project of analyzing and comparing different machine learning based on recommendation systems for movies. So it is useful as it reduces the search time and enhances user satisfaction by offering personalized content. This system also relies heavily on machine learning to analyze your behavior and match it with your content you're likely to enjoy. For example, when you watch a movie on Netflix, have you ever encountered like after watching a movie such as action movie, it will more likely to appeal the recommendation of a action movie as well, or movies that are actually similar to the previous movie that you have watched. That's the example of a recommendation movie system based on a machine learning. Now Janelle will walk us through on how machine learning actually works in this system, such as the movie recommendation.
Thanks, Dale. Now, let's take a look at how these systems use user behavior and movie metadata. First, they analyze your user behavior based from what you have watched, liked, rated, or searched for. This helps build a profile of your preferences. Then, they combine this with movie metadata like title, genre, cast, and release year. Now, this is where feature extraction plays a key role. Feature extraction identifies important patterns and characteristics in data. In relation to our topic, the system identifies your favorite genre, movies, actors, and etc. It also identifies meaningful traits from both the user data and movie data to understand what kind of content do you prefer. Once the data is collected, the system uses forecasting to predict what you will enjoy next. It may use collaborative filtering, which compares your behavior with similar users, or content based filtering, which matches you with similar movies. These systems also rely on sequence learning, a technique that helps models understand the order of your viewing habits. For example, if you watch a romantic movie followed by a drama, the system learns that the sequence and will now suggest similar combinations. Every click or rating becomes new training data in feedback loop, helping the model improve continuously. This dynamic learning process and ensures that the recommendations evolve with your changing preferences. Now that we understand how these systems work, let's explore their strengths and weaknesses. John Hope will now explain the benefits and limitations of this movie recommendation system and how advanced techniques like one-shot learning and convolutional networks are shaping the future of recommendations.
Thanks, Journal. So, one major benefit of movie recommendation system is personalization. Machine learning tailors suggestions to your unique tastes, saving you time and increasing engagement. It also improves user satisfaction by offering contents you're likely to enjoy. So, this system uses automatic learning to adapt to your behavior. They're also highly scalable, meaning that they can serve millions of users simultaneously. Platforms often use convolutional networks for this one, which is a type of deep learning model that excels at analyzing images. So these networks can evaluate movie posters, thumbnails, or even scenes from trailers to help determine what might appeal to you visually. This adds another layer of personalization based on visual preferences. Of course, despite of these strengths, these systems also face challenges. First would be the cold start problem. It occurs when there's not enough data about a new user or movie, making it difficult to generate accurate recommendations or making it difficult to be recommended. Aside from that is the filter bubbles, where users are shown only similar type of contents, which limits the diversity of content being recommended in their pages. Next would be the bias in trading data, which can also lead to unfair or skewed recommendations. So system may also suffer from overfitting, where they assume your taste is fixed and stop offering variety of contents. They also depend heavily on data quality. Inaccurate or missing data can reduce recommendation accuracy. So a promising solution for this kind of limitation is one-shot learning, where system learns just one or few example. So one-shot learning is a type of machine learning that aims to learn a new concept from a single example. This means that instead of requiring thousands or millions of labeled data points to train a model, one-shot learning can learn a new concept with just single example. This is achieved through the use of deep neural network, which are trained to recognize patterns and features in images. So one of the key advantages of one-shot learning is its ability to learn new concept quickly. This is particularly useful in situations where large amounts of training data are not available or where new concepts are constantly being introduced. This is ideal for recommending brand new content with minimal data, and it also allows the system to generalize quickly and adapt to new trends or releases. Before we end, let's quickly recap what we've covered. Movie recommendations are changing how we discover films. By using machine learning, platforms like YouTube, Netflix, or even Facebook analyze what we watch and combine it with movie details to suggest contents that fits our personal taste. These systems makes watching more enjoyable by saving time and offering personalized suggestions. But they also face challenges like struggling with new users, showing repetitive content, or being affected by biased data. Fortunately, new techniques like one-shot learning and deep neural networks are helping these systems to improve. They allow platforms to adapt quickly, even with limited data, and recommend fresh and relevant content. In short, machine learning is not just working behind the scenes, it's shaping what we see on the screen itself. And as it evolves, our entertainment experience becomes smarter, faster, and more personal. And that is all for our video. Thank you for watching.